In this chapter, we're going to see how to modify the Pygame layout. We are still focusing on the game of Breakout, and we have produced an output.py file. This output.py file contains a series of classes that are going to help us in the process of customizing and applying actions to the elements in our games. An important aspect of how the output.py file is structured has to do with the master class game object. All of the elements in our game have to share certain properties that make them appropriate for Pygame. In this case, a game object is a special object that contains certain attributes that will allow us to evaluate interactions of those objects with others and within the window. We have things like the position in X and Y, the velocity, which initially is not declared, is something that we cannot add in the layout, is added by default, but we can change it programmatically. We also have certain booleans, an image that refers to a particular path in our computer where we store the image that this sprite is going to take, etc. We also have some methods. The draw method allows us to place the pixels that represent the image that this sprite has in the screen, and it's going to be called procedurally using a for loop, which is one of the reasons why the categories, agents or foods or enemies, are nested within a list. The next one is the turn clockwise. This one is going to represent the rotation that the user placed in the layout, and is going to apply it at the beginning. It can be used later in the code depending on your necessities, but it's something that modifies the image directly, so sometimes it's better to make a clone of the original image and then start rotating. The update rect is something that will allow the placement of the hitbox of the object, which is an attribute that the image uses in order to know where it is located and where to present the pixels. And it's going to simply update the value of the hitbox to that particular position X and Y. Notice that here the rect component is located in the center, and that means that in the position where a sprite is, there is going to be half of the width of the image to the left and half of the width of the image to the right. Same happens with the height. Then we have the scale and the update. The update contains two helper functions. We of course are going to be able to add more as needed if all of the objects in our game require a very specific additional function, but some of the most essential ones include update position and update velocity. Notice as well that these functions are defined below within the class itself, but don't contain anything at this point. But because this game object is so general, it fails to address some specific details that the different elements in our games may have. Indeed, an agent is different from a wall, and a wall is different from an enemy, in the sense that some of these elements may be static. Some others may also have attributes attached to them, like a certain amount of health or a capacity to make damage, etc. So we need to create child classes. A child class is no other than the original game object class, but it is slightly modified to fit our needs, and that includes adding or modifying the functions that were already present in the parental class. In effect, it is a way to copy almost all of the attributes that the parental class had, in other words, all of these elements, but it will also allow us to add specific changes so that we don't need to recreate the parental class every single time. The game manager is the brain of our operations, where the elements inside of that class represent instances of the game object definition that we defined previously. This includes all of the elements that you specified during your layout construction, and it is structured in such a way that all of the elements, depending on their categories, agents, walls, foods, and enemies, contain their own list. We're going to start here, in line 141 in my code. And I'm going to change the name GameObjectAgent0 to paddle. This is the only agent that my game is going to have. It's not always the case, especially when you're simulating environments like farming simulators. You may have multiple agents. And I am also going to modify it here on the right notice that there is the semicolon in here that basically represents a new line over here. But in order to keep things compact, I added this semicolon to keep everything in the same line so that the user could read it. So I'm going to change this one also to paddle. These should be the only two locations where we find the name of that specific game object. Down here, instead of foot, I'm going to call it the ball, because it's not really an example of foot. It doesn't get taken over, it doesn't disappear, it simply bounces against the paddle. Now that we changed the name of one of the most important game objects, we're gonna begin by modifying the paddle. We're gonna start adding actions to it. To do that, we scroll down, and the first thing I want you to notice here is the simple structure that a Pygame layout has. So first we have the game manager, which is equal to an instance of the game manager class. So in other words, it's gonna create one example that contains all of this. Also notice that at the very top, our program created two hyperparameters. These are variables that are present in and accessible to the entire program. The first one is the screen, which at this point, because of the structure of the layout and the designer that we just used, is always going to be 600 by 480. You could change it if you want, absolutely, go ahead. But the distribution and position of your elements in the game may not be as expected. The next element is the display variable, which represents a way for Python to communicate to an object written in the C programming language that has the power to create pixels and present them in the screen. In the next line number 6, in my program, I'm going to create a new variable. Here we can create as many variables as we want. I'm going to call this the paddle speed. That is going to help later. And it's going to specify how fast the paddle can move to the left or to the right. There is 3 types of movement allowed in our paddle: the left direction, the right direction, but the third one, which is not always obvious in games, is nothing. We're also going to have to represent that direction. For now, the paddle speed to the left or to the right is going to be represented with a magnitude of 10 pixels every frame. Back at the bottom of the document, let's talk about the structure of this layout. We have the drop function and the update function. And this is always how you're going to structure things using a Pygame layout. The drop function is in charge of manipulating pixels. It is composed of 3 different actions. The first one involves using the object in C, called the display, and refreshing the pixels that constitute the background. This is the equivalent of refreshing the screen, and we need to pick a color for it. In the middle, we have a for loop that is going to go through every single game object in our entire game manager. And it does it by using a 2-level for loop. The reason is that the game manager contains a master list with all of the game objects, and inside of that list we have sublists that contain specific elements like agents, walls, etc. So that's why we need to unwrap it using a 2-level for loop here. For each of those, we summon the function that is already located in the master class game object to which this game object belongs, and we pass the object written in C that is going to be used to imprint the pixels of that particular object. Once everything is done, we simply ask Python to ask the programming language that actually renders the pixels to update the image, and that is done with this command called the flip. The second part is the update function, and the update function is where most of our algorithm takes place. It is where we specify the user input, the changes in the collisions between the different objects, the movement, the speed, etc. It really is where the rules of our game take place. We're going to start here in the update function. If we want to be able to move our paddle, we need to receive the user input. This line right here is a special type of loop that is expressed in a syntax that in Python is known as a list comprehension. This line right here is very simple and is simply asking for the application to listen to the user clicking the X in the top right corner of the window in Windows, or the top left corner of the window in Mac, in order to close the application. But now we need to listen to additional input. This list comprehension is equivalent to typing for every event in the list of events of Pygame. And that represents this part over here. This condition goes in here, and this action goes inside of the condition if the condition is true. So that's how we can defragment a list comprehension back into a regular for loop. Here, we're going to add another condition, and we're going to ask if the type of event is the user pressing the key down. If the answer is yes, instead of writing the code directly in here, in order to modify the paddle, we're going to ask for the paddle to access one of its own functions. So we're going to call the game manager, which is the object that contains the paddle, and we're going to type paddle followed by a dot. And at this stage, we don't have a function that listens to the events from the user, but let's wish that we had. And we're going to call this user input. Inside of the user input, we need to give information on what type of event we had. So that's what we pass in here. We're going to pass the event that the user typed, and we're going to let the paddle handle it. So let's create this function here. There is two candidates where the user input function could go. We could put it as a special function inside of the master class game object. But because of the structure of our game, which involves listening to the user input only for the paddle, we're going to place it in here. In the class agent, I'm going to go below this very weird looking function that starts with init. It's called the constructor. And I'm going to create a new function, user input. Oops, user input. This function, or technically speaking method, is going to receive self. All of the functions that are inside of a class receive self, and it's going to receive also the event. What we know is that this event is of a certain type, and this is pressing the button down. But that event contains many other attributes. If it is an event of pressing the button down, it also contains information on which key was pressed. So I can ask if the event key that was pressed is of type key right. And if the answer is yes, then we can modify the position in X of the paddle by the paddle speed. There is another version of this, and that represents if the key is not the right key but the left key. If the answer is yes, then we subtract pixels instead of adding them. If we go back to the bottom of the document where we are working with the update function, you will notice that now this user input, at least in VS Code, has now changed color, letting us know that the program recognizes that function. Let's run the program to see what happens. And if I press the keys, the paddle is indeed moving. So that's good news. That is progress. But perhaps to our disappointment, the paddle only moves once whenever I click the arrow keys. I like the movement to be continuous, because otherwise the task is going to be exhausting. So what we can do in this case is to create a variable that will contain information on the current direction of the paddle. Let's close this for a minute, and let's go back to the structure of our program. So let's go to the agent class. And here, next to this function called super, we're going to add a special attribute called direction. And what is special about this direction is how we're going to represent the three different cases for our paddle to move. Instead of typing as a string left, right, or nothing, which is the third type of motion, we're going to use a list. This right here is what allows AI systems, which are numerical algorithms, to receive input that allows them to understand their environment and also to change it using actions. we are going to represent the current direction as 0, 1, 0. Here we have a special type of list that is known as a one-hot vector. What is specific about a one-hot vector is that each of the elements has a binary value, and only one element inside of the list can contain the number 1. You can think about each of the columns in this list as being their own direction. You have the left direction, the nothing direction, and the right direction. So we have 3 cases. We have the 1, 0, 0 list, which is left. We have the 0, 1, 0, which is none. And we have the 0, 0, 1, which is right. At the beginning, the paddle is static and is not moving. So let's represent that here. So by the time that the user presses the right arrow key, instead of modifying the velocity itself, we modify the direction. We're gonna cut this from here for now, and we're gonna set this self.direction equal to our right direction. Let's copy this and paste it. The same happens with the other case, except we're gonna use the left direction. 1, 0, 0. At this stage, we're not gonna worry about the non-direction. That's gonna happen when the user releases the key. But now that we have this, we also need to apply the changes in position based on that direction. Notice that we got rid of the plus equal paddle speed. To do that, we're going to modify a function that is already part of the master class game object to which the agent belongs to. And that is the update position. So I'm going to copy it from here and I'm going to paste it down here to override it. This one is going to be in charge of using if statements to determine if the direction is right. Actually, let's start with left. And if the answer is yes, then it's going to apply that change in direction. Whoops. Self.x plus equal paddle speed. That's where it goes. Otherwise, if the direction is right, then we apply self.x minus equal paddle speed. We're almost done. If we scroll up, you will notice that this function update position is being called by the function update inside of the game manager class. That means that in order to call this update position, we have 2 options. We can call it directly as an update position if we're not going to update velocity and we're not planning on doing anything else. Or we can follow the structure of the class and call the update, which will take care of calling, among other things, the update position. Let's take the second approach, because it will help us familiarize ourselves with the general structure of that class. Back at the bottom of the document, we go through every single event in the Pygame window, and at the end, we called the game manager's object and access the paddle, and we call the update function of that paddle. If we run this now and we change the direction, the paddle starts moving, and this time it doesn't stop, which is definitely a problem. So we need to also make it stop, and to make it stop, we go back to the structure of the code in the update function that allows us to receive the user input. In here, we're going to copy this line and we're going to create a different case. Not when the key is down, but when the key is released or up. When the key is up, we need to also filter for a specific key. So we're going to ask if the type of key that was pressed is the left key, or if the key that was pressed is the right key, which is right here. And if the answer is yes, now we can call the game manager, the paddle, and set the direction equal to 0, 1, 0. I'm also going to change the paddle speed to 4 because it seems to be pretty fast. And if I run the program now, the paddle moves. Something that I'm noticing though is that the keys are inverted. So I need to fix that. You probably saw the issue. I'm gonna see where the error happened. So this is right, that's the right direction. This is left. Oh, that's it, that's where it happened. So I'm gonna flip these two like this. And instead of minus, this is plus, and instead of plus, this is minus. There you go. This time it should work. Now, taking the chance that we are here, another problem you may also run into is that right now the paddle can go wherever it wants, right? It can go to the right side of the screen and just keep going and disappear. There is no boundaries in that, and sometimes you press it so much, it takes a while for it to come back. So we need to restrict it to the boundaries of our screen. And to do that, we're going to use the attribute of the width of the image relative to the position of the first pixel on the left side of the screen and the last pixel on the right side of the screen, which represents the width of that screen. So we can put it, we're going to put it in here. So here we're going to place an AND logical statement, and we're going to ask if the position in X of the paddle plus half of the width of the image, because remember that the position of the sprite is in the center of that sprite, so half of the width is to the right, half of the width is to the left. And we can access the width by using the image followed by get width. Let's encapsulate this in here inside of the brackets so that it is easier to see, and we can ask if it is less than the width of the screen, which is the screen element that contains two things, and we access the first thing, which is the width. If the answer is yes, then you can move towards the right. Let's copy this and the statement because the second one is nearly identical. Instead of asking for the right half of the image, we ask for the left half of the image, and we also need half of the width. Sorry, it has to be half of the width. And instead of checking if it is less than the maximum width of the screen, we ask if it is above the very first pixel. Let's run this again. Hopefully it works. And fantastic, it does. So that is how we can program the paddle. The next thing we need to do is to make sure that the ball updates its position, and then we can evaluate interactions.